Oh,
Yes, ma'am, you can start.
Good evening to one and all. A very warm welcome to the 10 days International Research Methodology Workshop in hybrid mode organized by Sociology of Sports, Indian Sociological Society, New Delhi, and Center for Study of Social Inclusion, Pondicherry University. I am grateful to Dr. Bennett Rajadurai J., Coordinator, Research and Development Cell, Secretary, Perspectives in Social Work, Mumbai, and Sociology of Sports, Indian Sociological Society, New Delhi, and Center for Study of Social Inclusion, Pondicherry University. I just want to introduce about our trust. So, Vanama Art Educational and Cultural Trust was established way back in 2005 with the underlying objective of promoting, developing, creating, sustaining, and improving the art and cultural heritage of India. So, the main motto is to raise raise our own selves and then raise the downtrodden in the society. So it was started by Lineate Vanama Jnana Prasunna, who was a cine playback singer and exponent of Carnatic classical and Hindustani light music, and also by my father, Lion VSDP Pullara. He was president of Lions Club of Vijayawada, YMCA Vijayawada, and so on. So at present, I am working as associate professor in the Department of Historical Studies, Government Arts College, Nandanam, Chennai. Coming to the objectives of the trust, we would like to promote research for the advancement of knowledge, enhance skill-based and vocational training and education of every kind to the youth as well as to the elders. So we have instituted shields for students in the year 2006 at Loyola College, and we were also publishing books and research journals. So this is a book released by former Law Minister Asif Pasha and Nizam Trust Board member. And this is another book release by the former Governor of Tamil Nadu, Dr. K. Rosaya. And next is like we are conducting annually national and international seminars. So in 2017, we have conducted a national seminar at the University of Madras. And in 2018, a symposium with the Pondicherry University was conducted. Later, a national conference by name Formative Facets of Folklore was conducted at Madras University. Former Vice Chancellor Professor P. Doraisamy has inaugurated the session. And we have also conducted, we have extended our activities to other states of India. So, international multidisciplinary webinar was conducted during the Corona period at Kamala Nehru Memorial National College at Shimoga, and later a virtual international workshop was conducted at Madras during the Platinum Jubilee year of the Department of Anthropology in 2021. And last year, an international summit was conducted. It was inaugurated by Dr. S. Elumalai, Registrar, University of Madras. And this year, an international conference on culture on crossroads was conducted at Madras University once again. And the registrar, Dr. S. Elumalai sir, and Dr. Sparnamalya, dancer and cultural historian, has inaugurated. Once again, I thank Dr. Bennett Rajadurai for giving me an opportunity to collaborate with this prestigious institution. I welcome one and all. Sir, his voice audible? Bennett, sir? Bennett, sir?
Yes,
Yes,
ma'am.
yes, ma'am.
Yeah, I've just gave a small introduction about our trust, sir. Thank you.
Yes. So thank you so much, ma'am.
Yeah,
Without
thank
taking
you.
much time, let me
Yeah,
directly
always.
hand over the session to our resource person,
Yes,
since
sir.
we have a lot to complete.
Yes, sir.
Requesting
Thank you,
you
sir.
to mute yourself.
Yeah, sure,
So
sir.
if you have any doubt, we are having a separate session for the question and answers.
Okay,
Definitely,
sir.
all your questions will be answered accordingly. Thank you so
Yes.
much. Without taking much time, let me hand the
Yeah.
session to Shobana Silvaraj.
Thank you, sir.
Over
Thank
to
you,
you,
sir.
ma'am.
So, good evening, everyone. Am I audible?
Yes, ma'am.
Good evening, ma'am.
Good evening.
Good
Yeah,
evening.
good evening,
Good
ma'am.
evening.
Yes, ma'am. You are audible.
Thank you. So, I welcome all the participants again for the third day of this international workshop in the technical session. So, continuation to the work we were doing yesterday, we will start our work on the same Excel sheet which you have been given in the last lecture. But today we will take the sheet named regression. So kindly get all set ready with your data, your Excel sheet. We'll wait for 2 minutes. Because still many of them are gradually joining. So till then, others you can get ready with your system and take your Excel sheet, which has been already shared with you yesterday. Okay, so I hope that you have been ready with your Excel sheet. So coming to the topic of regression. So the last two sessions we were discussing about the descriptive part, descriptive statistics, in that how to summarize your data in chart and how to give a numerical summary of the data. So one thing, if you have noticed, it was just one variable at a time we were working. Suppose if it is salary, salary is just and one variable at a time. Then The next variable was say PhD, number of PhD school students under the particular faculty. That was again a quantitative type of data. And we had computed the descriptive statistics separately for that, that is independently. So at a time we were working with one variable. If suppose if I take them together in the input range also, when you get the response, that is the result, you're going to get separately for a PhD column, you're going to get separately for the salary column. But now the topic which we are going to do in regression, that is when we go for regression, that is when we come across with more than one variable at a time, having some relation between them. So if you find that I am in a particular data, I am having more than one variable and say one being dependent variable and another being independent variable, then I try what in that? I try that, or I try to find whether there is any relation between the two variable. Next, what type of relation it can be? It can be a linear relation or it can be a non-linear relation also. How will we identify that the type of relation? That is again by our basic chart. If you recall our first day session, when we have two variables and when I want to plot them, it is nothing but the scatter plot. So using scatter plot, to some extent, I can understand the relation between two variables, a visualization part. But further, what I can do with that, we will go for regression analysis to check whether a model can be built with that data for the further prediction. So that is what about regression analysis is. So here I have taken an example for you where I am having say 8 variables and the description of the variable type is also given to you in the column K and L. Variable types are of continuous, multi-valued, discrete, or say string. The first thing which you have to note for regression analysis, to some extent which we can do in Excel, is the linear regression analysis. The non-linear regression analysis is a limitation over here. Direct method is not there, like one click, one answer, no. So we can do only till linear. So today I'll be teaching you about linear regression in Excel. When we will be coming in our later end of the sessions of the SPSS, maybe in another 2 days. So in that one of the session, we will be seeing one of the non-linear type of regression. Okay. So assumptions, as we all know, when we do the max problems, of course, we have some assumptions. Same way, here also some assumptions should be satisfied, or some assumption, or the particular work can be done for this type of data only. Hence, type of data is very important, quantitative and qualitative. Linear regression is possible or is applicable only for quantitative type of data. Linear regression is possible only for quantitative type of data. Okay, first thing. Again, in that also, the type further, the variable type, it should be continuous, not discrete. Our data should be continuous variable. Okay. So if you see in our data variable which is given to us, the MPG, that is miles per gallon value given, it is in continuous. Then displacement is in continuous. Horsepower, weight and acceleration is in continuous. So we can take these values for our linear regression analysis. Now, when I say linear regression analysis, I have two types of linear regression analysis. That is simple linear regression and multiple linear regression. Simple linear regression and multiple linear regression. So how will you identify, or how will you know when I have to go for, I think one of the participant mic is on, from where I'm getting an echo. Okay, sorry. So when we can say that, or when we will go for simple linear regression, it will depend upon our independent variable. So how many variables we will be having in regression? In regression, we have how many variables? Two variables. That is independent variable and dependent variable. So I can say, if I am checking the cholesterol level, so my cholesterol level can depend on other variables, right? So the cholesterol level would be my dependent variable, and it will be depending on some other independent variables. So when I am having only one independent variable, then the linear regression is called as simple linear regression. And when I have more than, that is more than one independent variable, then we say it as multiple linear regression. It is called as multiple linear regression. Of course, for any of the case, your dependent variable is going to be only one. You will be having only one dependent variable. And how do we write our model? Y equal to beta naught. This is the statistical notation. If I want to make you aware of that, you also know something which you have learned in your lower class. That is nothing but, if you remember a straight line equation, what we say, mx plus c, or y equal to a plus bx. These are the different form of presenting the simple linear line. We say straight line. But when I use the notations for the model, then we use say beta naught, beta 1. And when I say regression, there is a very important term called as error. Because when we estimate, when we predict, of course, an error term is always involved in the model. Right. So let us see now how to perform this, and then we will come to this fitting of model, how to fit a model and interpret it. So first I will start with simple. That is, of course, in this case, the problem is what? To identify which variables are infusing the miles per gallon, that is the fuel consumption. So here are the different variables given to you on which your fuel consumption depends. So from this, it is very clear that your fuel consumption is your dependent variable, and it is depending on, say, cylinders, displacement, horsepower, weight, and acceleration. But since cylinder is not a continuous type of data, we cannot take that variable for our linear regression. Okay. So hence, the other variables like displacement, horsepower, weight, and acceleration are the variables which can be used for our regression model for the prediction part. Right? So now starting with the simple, so for the understanding purpose, I'm going to take only one independent variable. So let me take a new sheet where we will work. So we are going to take only one independent variable, say displacement. So you can remove the signal cylinder. So these are the two variables we are going to take now. One is your independent variable and one is your dependent. One independent variable is called as simple linear regression. Okay, so the procedure is going to be the same. That is, you're supposed to go to data. In that, you will go for data analysis. You will get an option called as regression. Kindly find that option regression and click on OK. So once you know one of the techniques to do, remaining is going to the similar way process. Just you should know what to put where, that's all. So first it is asking me input y range. So here you should know what is my y variable. So here my MPG is my y variable. So of course you will select with your column name in y, and then coming to x. Next it is asking you to input your x range. So in that I will put the B column data. That is my displacement. Of course you have to select label. And always by default we take 95% confidence level. That is, my level of significance would be 5%. So I will come to that point. What is this level of significance and confidence level? First, let us get the output. Then I will explain you what is this confidence level mean. Output range, up to you. I'm taking on the same sheet, and these are some of the extra stuffs. If you are interested to know the residual, the plot, this is all your later part work. Okay, first let's understand the model part. Just click on OK and just see whether you have been got some summary output in this format and get it ready. And then we will go for the interpretation part of this. So I hope you are sitting with your writing materials,
Ma'am, please
because
repeat.
you have to write down some.
Ma'am, please repeat the process.
Yes, you have already installed the data analysis tool pack, right?
Yes, ma'am. Regression. I have.
So yeah, then you have to put the y range. You have to put the y data in the y range. That is my first column, which has MPG data. And in X, input X range, you will put the
displacement.
Yes, displacement value.
Okay.
Then select all these options, labels, confidence level, output range, give a cell, and then click on OK.
Okay.
Ma'am, hello.
Yes.
Ma'am, for me, after giving everything now, it shows like a regression having trouble to offset input or output reference like that it's showing, like a pop-up menu it's showing.
Then just repeat once again.
Can I share my screen, ma'am?
Ma'am, I
Your-
had a doubt like MPG.
Your version is licensed now. It is not a trial one, right? It is licensed one, right?
Yes, ma'am, I think so. It's a licensed one.
Because yesterday the same problem was with one of the participant.
Mhm.
If it is not a licensed one, then you can't perform everything in that.
Okay, ma'am, okay.
So kindly check at the top what it is written in Excel.
Ma'am, what output range?
Sorry, output range,
Ma'am,
any one of
I think
the
it's
blank cell. Any one blank cell.
Okay, ma'am.
ma'am.
Always,
Can you repeat
any
once?
analysis you do, output range would be only a blank cell. So I'll wait for
Mind
2-3
repeating
minutes.
once more, ma'am?
Sorry.
Would you mind repeating once more?
Yes, sure.
Because due to connectivity issue, I'm not able to follow.
Okay, I will repeat the step once again, Sam. You have to go to data analysis tool pack. In that, regression option is available. You click on OK. You have to put all the stuffs which is asked, like input your X range, input your Y range. That is, you have to put the Y value and the X value. In Y range, you are supposed to put the MPG column because that is my dependent variable in this data. My X is my independent variable, that is displacement is one which we have taken. Then you will select label and confidence level. By default, it is 95%. Currently select that and click a blank cell in the output range and OK. Fine. So now we have to build a model. Now see how you have to build a model. I will show you the model, standard model, how it looks for a simple linear regression. Just before I showed you in Excel something called as y equal to mx plus c, y equal to a plus bx. These are the equations which we are familiar, which we say it as straight line equation, and it is used to find the slope and say intercept, right? But now when I say in regression, I say it as a model. We use the very technical term, say model. And how do we fit a model? We identify the parameters. Here I will not say slope or say constant or intercept, but I use a word called as parameters. And what are the parameters over here? It is my beta naught and beta 1. Currently, you can just try to relate this expression with the previous one which I have written, y equal to a plus bx. That's all. It's not nothing hard in this. The term which is to be added here is the error term, since it is a model which is used for prediction, and whatever we do estimation, there is an error present in that. Okay, that's all. Only the notation is going to differ, and the name is also called as now as parameters, but the meaning is same. Beta naught is your intercept and beta 1 is your slope. But as a model term, we say it as parameters. Okay. Now, how will you build the model from the output which we have got? Now, coming back to our output screen, that is my Excel. Okay. So here you have got, let us start with the summary output. So many informations are given to you here. Summary output, regression statistics. So what all is actually required for our interpretation part here. First most is my R square. My R square will tell you how much % of information is being explained by the independent variable. In simple layman term, here suppose if I am having my R square as 0.69, so just convert into percentage form. So it will become what? 69%, right? So it is approximately 69.66% variation has been explained by this independent variable. Now, what do you mean by this independent variable? In this sum, it is by displacement. In this problem, it is by displacement. That means to predict the MPG, 69% role is by the displacement, and the rest percent, that is the rest nearby 31% is due to some other variables. Am I clear to everyone till here? I'm repeating once again. Predicting the miles per gallon value, displacement value plays a role of 69% approximately, and remaining 31% is due to some other variable, some other variation. That is the meaning of R square. And generally, we assume that our R square should be quite more than 60. And we assume that our model is a good fit model. If it is more than 60, to some extent, we can say that our model is a good fit model. Okay. Is it clear about what is the meaning of R square? In simple term, how much variation is explained by our independent variable. That's all. So more it explains, more good is the model. Approximately till 60, we can assume that it is a good model. Okay. So when it is simple linear regression, we have the role of R square only. R square plays an important role. We are not concerned with the other variables. That is other values. Multiple R square, that is the adjusted R square, is used for multiple linear regression when you come across. Okay. Of course, standard error has this similar meaning. What is the standard error of your estimate in this given case? Next, coming to the main table, ANOVA table. Now, what is the interpretation, or what interpretation can be used? Which value is used from the ANOVA table? You can see the last value, significance p-value. That is significance F means it is the p-value which we say in any of the tool pack. Any statistical package you go for, you are going to get the value, something called as significance value or say p-value. That is the value which we generally use, the standardized one, to make the conclusion about our hypothesis part. So when I want to give a conclusion, when I'm saying, of course, I have to state the hypothesis. So when I'm saying hypothesis, so here comes the inferential statistics, the second part of the second branch of the statistics. Hypothesis is nothing but a statement, a statistical statement which I want to test. So there are two types of hypothesis, say null hypothesis and alternative hypothesis. So the claim which is given, the claim which I want to test is generally it is in the alternative hypothesis, and in null hypothesis we have the not of that. And there is a standard way of writing the null hypothesis too. So let me write the statement for you, how we write or the statement. So here first we are going to see, so I will write in the below of the summary table. First thing, in regression, once we perform, we have to see, that is, we have to check the overall significance of the model. This is the first thing. You have to check the overall significance of the model. If overall the model is significant, then only you can build the model or use that model for prediction. Okay. Once you have done with this, if this is significant, then we go for the second one to see whether that is our independent variables are significant. Whether our independent variable or say independent variables are significant. This is the next one we have to do. If all this is done, then only there is the use of the interpretation of the R square value. Otherwise, there is no use to understand how much variation is explained if there is overall the model is significant or not. Okay. So to check this, so to check the claim, of course, we have to write the statistical hypothesis here. So we, as stated, we have two hypotheses to be stated, say null hypothesis and alternative hypothesis. Okay. So the standard format of writing the null hypothesis is there is no significant, that is no value, no significant word should come in our null hypothesis. So what we will write in the null hypothesis for checking the overall significant, overall the model is not significant. So what we will write here, overall the model is not significant. Then the alternative will be just opposite of that. Overall, the model is significant. This is the standard statement which we write for checking the overall significance of the model. And how will you come to a conclusion? We have a standardized decision rule. We have a standardized decision rule when we compare the value with the significance value. If you are having the significance value, then we have to go through this standardized decision rule. So the rule says, if my p-value, that is in some of the tests, they will write it as significance value. If my p-value is less than LOS. Now, what is this LOS? Level of significance. So if my p-value is less than level of significance, we reject the null hypothesis at that level of significance value. Now, here I have to explain or make you understand what do you mean by level of significance. Starting with a very simple example to make you understand where we in real life situation we all have come across. You have been attempted a paper and you're waiting for your result. Once you have got your result in your hand, and if someone is asking you how much percent you have got, can you say the exact percent which you have got, which is in your mark sheet? Isn't it? Whatever may be the percentage, you can say, looking at the mark sheet, this is the percentage you have got. Okay. So this is what specific value. You're giving the specific value which is there in front of you. But you have attempted a paper and you are waiting for a result. The result is not yet out, but the people around you have started asking you for how much you may get, how much you may get, how much you expect. Right? These are the words which we have been come across. Then how is your response to that person's? How do you respond them with? Can you give the exact percentage which you can get, which you will be getting? We can't, right? We can't give the exact percentage which we may get in the mark sheet. Hence, what do we say? Above 60, above 70, above 90, or say 80 to 90. This is what your answer may be, right? If suppose if you don't know your result. So the response which you gave, the answer which you are giving above 80. So what do you mean by above 80? 80 to 100, because the maximum is what? 100. If I'm saying below 50, so what do you mean by below 50? 0 to 50, because minimum you can go till 0. If you're saying 70 to 80, then that is the interval which you can expect. Okay, so this is called as what? Interval. Now my next question in this is, how much confident you are in your answer? Are you 100% sure that you will get more than 90? Or you will get between 60 to 70? Again, is it 100% sure? Not always, right? We can't give an assurity on that. It can go below 60 also, or if you're saying 60 to 70, it may go above 70 also. Isn't it? These are the different possibilities. So when I'm saying 95%, I am confident that I will get between 60 to 70. So the 5% which you're having a doubt, that is nothing but your level of significance. I hope you understood with this very basic example. So when I'm saying the level of significance in another term is nothing but the maximum allowable error. So maximum 5% chance that you can make a mistake. That is, there can be error in your prediction. But rest 95% you are with your interval. If I'm saying that 80% I am confident I will get between 60 to 70, that means 20% chance that you may get out of this range. That 20%, the risk which you're saying, the error which it can be, that is your level of significance. Is this clear to everyone about the level of significance part?
Ma'am, can you explain it one more time?
Now you see many of the advertisements. If they give any advertisement of, say, a cosmetic type or a cosmetic product, the best one which we see every day in the advertisements, say about the Lysol or the Dettol for the germ kills. At the end, what is mentioned? 99.9%, isn't it? So they are confident with their survey, with their test, whatever they have checked with their product. They are not giving 100% assurity, because we cannot give 100% assurity since we cannot check the complete population. They have worked with some sample. From that, they have come to an conclusion that 99.99 they are confident. Because for a safer side, we have to always keep some percent of error, because you cannot be 100% sure with your result. sometimes there can be an error. The error which is allowable is nothing but the level of significance. So when I'm saying 99% gem kills, it means 1% chance that that result may go wrong at some particular situation. That is what level of significance is. Okay. So when you were performing the regression, by default, confidence level in that was 95%. So in statistics, we generally take three values, 99%, 95% and 90. Among them, the standard one which we take is 95. Because when I say 99%, so it is very too risky that you are just giving 1%. The meaning is 100 times you are doing something and you say that I'm going to make only once wrong, one time going wrong. So that is very risky. And when I'm saying 90%, so you're too low confident with your work. So not very too low confident or not very overconfident. So between them is what we generally take is 95%. Okay. So we take a 5% level of significance. So the meaning is, suppose if I'm doing 100 times some experiment, 95 times my value will lie in that interval. 5 times it may go outside the interval. That's all. Okay. So now let us come to our decision to see whether the overall significance of the model, which is can be done with the help of the significance value. So here my significance value is 7.08. So don't see that 7.08 and get little worried how big it is. See the end. It is E minus 65. Now what do you mean by E minus 65? E minus 65 means 0.64 times 0 and then the value. For example, if I am having 4.5 E minus 0.4, the meaning is it is 0.123 zeros and 45. So the E is nothing but the exponent, what we write 10 raised to minus. Okay, that is what the meaning over here is. So when I'm saying 0.64 times 0, so the meaning here itself, it means approximately my value is what? 0. Because generally we take 4 or 5 digits only to round off. So here I can say this value is approximately 0.000. Now this value I have to compare with which value? See the decision rule. My p value or the significance value should be compared with what level of significance. So what is the level of significance you have taken here? 5%, right? So I have to compare this with 5%, 0.05. Even if you compare with 0.01 also in this case, that is 95%, they also, this is going to be very much going to be the close result. Now tell the sign which I have to put. Is it less than or greater than? My p value is less than or greater than when I compare with 0.05. Yes, participant, it is not a difficult.
Less than 0.5.
It's less than.
Less
Less
than.
than, ma'am.
Okay, it is less than. Thank you. So according to the decision rule, if it is less than what we are supposed to do, we have to reject the null hypothesis. And what is the conclusion we have got here? My overall, the model is significant. Overall, the model is significant. Because overall, if the model is not significant, you cannot use the regression model for prediction. So this is very important to check the significance of the model. Okay. So here, this is the conclusion we have got. So I will put in green. This is what we are now considering. Now, once the overall model is significant, we have to check whether the independent variable is significant. Now, this is not necessary. This is not necessary for simple linear regression. We write the short form SLR. This test is not required to check for SLR because I'm having only one independent variable and the p-value which you have got, it is for that based on that one variable only. How will you identify that? Come to the next table here. Can you see the table which I have highlighted now? In this table, okay. In this, can you see in column H something called as p-value? And closely observe the p-value of my independent variable. That is the displacement, okay? The p-value of my independent variable, that is displacement. I am highlighting for you. And see my overall significance value. These two values are going to be same for SLR, that is simple linear regression. And if it is SLR, no need to check separately for individual variable because it's one and the same because I'm having only one variable. Okay. So you can write directly that this one variable is, that is the displacement independent variable is significant for this model. Correct. Next, the main part, building the model. So to build the model, we have to have our coefficient value. Okay, this is the part which we have to now consider for our coefficient value. So if you have noted the model format, y equal to beta naught plus beta 1 x. So according to that, what I will be writing here is just increase the font size. I have to write the significant model is y equal to beta naught. Beta naught is nothing but my coefficient of the intercept. That is 33.5576. You can take 4 digits after the decimal. Minus this plus beta 1, na? But my coefficient of my beta 1 is minus. So plus into minus is minus. So minus 0.0546 into x. Now you should be very specific. What is my y in this case? MPG. So I will write MPG, which is nothing but my y variable for your understanding. And your x. So x means which variable in this case? It is my displacement. Is this clear to everyone how to build the model? Just using the coefficients obtained in the regression summary. Okay. From the regression summary, the coefficients which we have obtained. So this is how the regression analysis is performed and interpreted. Very important thing before doing this is to see, to get the idea about how the table. So just I first wanted to help you out the interpretation part, which is very important. But to perform all this thing, one of the assumption is very, very important. That is checking the normality assumption. If you read the content or the notes of the regression analysis, there are so many assumptions to be satisfied: normality, heteroscedasticity, autocorrelation, multicollinearity, for etc., which is all for our multiple linear regression part. But the very, very important thing among everything, the which is common in simple and multiple, is to check the normality of your data. Normality of the data to check in SPSS is direct. We have one of the analysis. We don't have a particular analysis type in Excel to check the normality. But with one value, to some extent, we can. That is the value which we were discussing in the last lectures about the descriptive part. If you remember, I have highlighted that also in that during that time, and I mentioned, I will explain this when it is required, the skewness and kurtosis meaning. Your skewness will tell you about how much about the normality of the data. So we have a standardized value here. We have a formula also. That is, the function is equal to SKU skew. When you click on this and when you select the data, for example, if I'm doing here for salary, so you can see here the value is same. Okay, you do by the function or you do by the descriptive analysis, you are going to get the same value. But how are you going to conclude about the normality of the data? So we have a range. If that value is between that range, then we can say that my data is normal. And one more thing is simply plotting the histogram. That is the reason I explained in the last lecture about the histogram. So if you see here, we have seen the histogram for the THT value. In the similar way, if you are able to put the salary or the dependent variable, which whatever we are going to do in regression analysis, that to some extent we can say whether my data is normal or not. And the best one is, of course, with the help of the statistical tests like Shapiro's, Kolmogorov, but which is the limitation which cannot be done in Excel. So when my skewness value is close to 0, I say that my data is normal. That is symmetric, the word which we use. Now, what do you mean by symmetric here? That is when you draw a curve. If you see this histogram, the graph looks like a bell shape. If the graph looks like a bell shape, then my data is normal. So if you see in this example, which I got it, the summarized one, beta and the number of percent. So to some extent, it looks like a bell shape. Okay. So here in Excel, we can just assume. We can't say significantly. Hence, to say significantly, we use the other packages like R, SPSS, Python, etc. Okay. So in Excel, in roughly, we can say with the help of the histogram and the skewness value that my data is normal or not. Okay. So when I say now this example which we have done, if you see it is clearly, it doesn't look like a bell shape. My graph, my bar is coming down towards the right hand side, right? Then we say it as right skewed. And similarly, if my bar comes down towards the left hand side, then we say it as left skewed. So it should be almost like a bell shape. Then we say it as symmetric. So hence, I had directly shown you the regression analysis because in this we can't do the actual statistical significant test to check the normality. But to some extent, if my skewness value is close to 0, or by plotting the histogram, I can say my data is normal or not. Okay. Now next, then we can use this significant model. Like this, you can take any of the independent variables one by one and you can go for a practice once we finish this session. You can practice with one more variable and see whether you are able to get this output. I'll give you 10 minutes. After that, we will go for the multiple linear regression part. Okay, here I have to explain you one more thing about this coefficient. Yes, very important thing. If my coefficient of the independent variable is negative, that means there is an inverse relation between them. So one variable increases, the other decreases. If it is positive, then both are in the same line. So this you can understand very clearly again by just plotting a scatter plot. Just select both this column data, go for insert. In charts, see, this is a very clear picture which you are getting. Is this visible to everyone, the chart which I am showing you? It is decreasing, na? Downward. Downward means what? One is increasing, then the other is decreasing. Because of this gives a rough idea about the relation between the two variables. Okay, so if one increases, the other decreases. Hence, the coefficient was negative. If you see here, the roughly of the histogram, can you see it is not, it is starting and then towards to some extent. Because when I'm saying 0.3, some may feel that it is close to 0. But what value we say close to 0? 0.00 some value. Okay, because when we say continuous value, around 4 digits. So 0.000 when we have, then we can say roughly. So here in Excel, we can only say roughly. Hence, it is a small limitation over here. This roughly is not a proper word in interpretation part because we are not able to use the word significant. And that can be done properly and accurately with the SPSS software or say R software, During that time, I will show you the same example only. And with the normality test, we will write very clearly whether my data follows normal or not exactly. But from here, we can get a rough idea. See, it is again, this graph is also towards the okay. So first thing is, as I said, we have to always plot a scatter plot diagram, which will give you a clear idea. And when I want to draw the histogram, we generally draw for one variable, that is for the y. So it is towards the down part. Okay, one-sided. But this is how we interpret the output which you get. In the regression analysis. Okay. So you can just practice with one more variable. Then I will go for the multiple linear regression quickly, because if you understand this, that is going to be simple. Hence, I have taken enough time to make you understand this part. Anyone is having any doubt in that? In this simple, you can ask me till.
Ma'am, can you one more time explain how to check whether the overall model is significant or not?
So it is decided based on the significance value which you can see in the ANOVA table. And kindly follow this decision rule, the standardized decision rule. If my p-value or say my significance value is less than my level of significance, then we reject the null hypothesis. So here my p-value was less, so I reject the null hypothesis, which is stated as overall the model is not significant, because that is the standard statement which we write for regression analysis. And hence my the model is overall significant in this case.
So, ma'am, how do we have to decide the significance value, or is there a specific significance value already given?
No, that will be computed by the software. When you perform the analysis, see here, the value which I highlighted in yellow, that is computed. That you compare with the level of significance.
Sorry, ma'am. The question was, do we have to decide the level of significance, or is it?
Yes. Standard one is 95%, which we decide. You can take 99 also, you can take 90 also, but the standard one is 95.
Okay. And how to see the difference? Like, do we have to subtract from 95?
We have to subtract it by the confidence interval. If you're saying, if you want to give a statement that 95% you're confident, then the 100 minus 95 is 5. So 5% will be your level of significance. If you are confident with 99%, if you want to give 95% confidence with your result, that means, 99%, then 100 minus 99 is what? 1%. So 1% level of significance.
Okay, ma'am. Thank you.
Ma'am, how did this green ELT.HYPO appeared? It is not appearing.
Sorry, which one?
Ma'am, the thing you have written, we have to check the overall significance of the model, and then ultimate.hypo, it is not appearing green. in my Excel sheet.
Sorry, pardon. Please, can you please repeat some disturbance in on the when you spoke? Sorry, one more time, please. What is
Ma'am,
not appearing in your system?
ma'am, the formula which you have performed, it is not exactly appearing in my Excel sheet. That is the ELT.HYPO. Overall, the model is significant. It is appearing green here, but it is normal in my Excel sheet. I think I have did something wrong.
No, no, no. I only made it green.
Okay,
Just
you
for
have made
your.
it green.
Yeah. I made it green for your understanding that in this particular thing, this is the answer. So I have highlighted in green for your reference.
Okay, and ma'am, the significant model is the thing which you have written in bold. That is also made by
Uh-huh.
you. Okay,
Yeah,
ma'am.
I only typed that. We have to type only.
Okay,
You
okay,
have to
okay.
type it from this. I have highlighted the yellow color, na coefficient value. From
Yes,
that,
ma'am.
I have typed it in that format. Did you see the? I'll show you once again the model for you. I hope you have seen this slide. Y equal to beta naught plus beta 1 x.
Yes, ma'am.
We are substituting my beta naught and beta 1. Beta naught is the coefficient, intercept coefficient, and beta 1 is the independent variable coefficient.
Okay.
Okay. And when we will be doing now multiple, in that case, it is going to be in this format. Beta naught plus beta 1 x1 plus beta 2 x2 plus so on. How much of a variable you have, that much betas will be added in your regression model. Okay. So if I'm having more than one xi, then it is called as multiple linear regression. Okay, so let me show you how to perform that and the interpretation part of that again for the multiple. So let us go to our regression data.
Also, ma'am, can you one
Original
more
data
time
set.
tell the significance of normality test? That why do we need normality test?
This is one of the assumption of the performing a linear regression. It is one of the assumption of regression analysis. Okay.
Excuse me, ma'am. Excuse me,
Yes.
ma'am. Ma'am, I'm very sorry. I was traveling, so I'm very late. Ma'am, will I get recordings later the class?
I think so. Bennett sir will be managing that.
Ma'am, from where I will get?
Bennett sir will inform you, I think, in the group about that, ma'am, later on, once you complete all the 10 days session.
Okay.
Yeah, he
Okay.
said in the first day they are working, and the technical person is working on that.
Okay. Thank you, ma'am. Thank you, ma'am. I was worried how I'll manage.
Okay. No worries.
Okay, thank you, ma'am.
Okay. Now let us go for the next half of the session, that is multiple linear regression. Once you are okay with simple, then multiple is going to be very simple because it's the same thing with more variables added. That's all. Okay, now let us take the remaining continuous variable also. It is displacement, horsepower, weight, and acceleration are my independent variable, and MPG, that is miles per gallons, that is fuel consumption, is my dependent variable. So procedure goes the same. Data analysis. So go to data analysis, regression. Okay. So your Y variable is the A column data only. But now in X, you are supposed to take all the independent variable together. That is from B, C, D, and E.
Sorry, ma'am.
Okay.
Please, hello. Hello.
Yes. Hello. Yes, yes.
Yes, ma'am. Please revise this process again. I was missed it due to network issue.
The steps are same as simple. You will go to data analysis, regression, and you're going to get the same dialog box. Input the Y range, you will put the A column data, that is MPG, that is your dependent variable. And in input range of X, you have to put all the independent variable together now. So you will see to that all your independent variables are adjacent. There is no other column in between them. Any unwanted column, that was the cylinder, was the unwanted column in this, you can remove that. You can delete that column and only take the necessary column in your new sheet. Put in the X range. Labels, confidence level again 95% by default. Output range and go for OK. So you get the summary and I'll give you 5 minutes. Please kindly perform. Then we will go for the interpretation part. Let us see some interesting result. The difference in taking one variable and taking more variables. Okay.
Hello, ma'am.
Yes.
Ma'am, can you please tell us the input X range, what we have to type?
You have to select all the input variable, independent variable, ma'am, from C, B column, C column, D column, and E column complete.
Okay,
From
okay.
first row to the last row, all the 4 columns.
Okay, ma'am. Okay.
And drag the complete values.
Okay.
So once you have done, please give me a confirmation, few participants, so that we can go for the interpretation part. Okay. So
Ma'am,
firstly,
what
have
I
to
will
check
select for Y range के लिए what I will select, ma'am?
फर्स्ट कॉलम मैडम MPG आपका वो सेम ही रहेगा, Y कॉलम आपका सेम ही रहेगा.
Okay, okay.
Because dependent variable is going to remain the same.
Okay, ma'am. Thank you, ma'am.
Shall I proceed?
Yes, ma'am.
Yes, ma'am.
So first we have to check the overall significance. Now you will help me out to answer all this. How will I conclude the overall significance of the model? Which value will help me out?
R square.
In this from this table which we have got.
Significance F 3.30.
Very good. M, it is in M column 3.30, but if you see ahead, it is E minus 71. That means it is all approximately what? Approximately 0.000 only, right?
Okay.
It is approximately 0. And I have to compare this with which value? 0.05. So it is again less than. So I can say, what is the conclusion over here then?
Less than 1.
That is, overall my model is significant, right? Overall my model is significant. So I can say overall model is significant. Now once overall model is significant, what
Ma'am,
is your
can you
next?
one more time?
Ma'am, can you please repeat this step?
Step for performing or interpretation part?
Interpretation and also performing.
Is this clear, this step which we had performed in the simple linear regression? The same step we are going to follow. The first thing is what? We have to check the overall significance of the model. How will I check that? With the help of significance F, which we obtained in the ANOVA table. So in this example, the highlighted value is my significance value. And it is approximately 0. That significance value I have to compare with my level of significance, and the standard level of significance which we take is 5%. So 5% means 0.05. And what is my decision rule? If my significance value is less than level of significance, we reject the null hypothesis. And what is the standard statement of defining the null hypothesis to check the overall significance of the model? In my null hypothesis, we define overall the model is not significant, and alternative hypothesis, overall my model is significant. This is the standard statement of defining the null hypothesis to check the significance of overall model. Okay. In my case, my p-value is less than the level of significance. I reject the null hypothesis. And again, this statement is going to be the same. Overall, the model is significant. That is, my overall model is significant. Okay. So what is the second step? If the overall model is significant, then my next observation, my next task is to check my independent variable is significant or not. I'm coming to the slide again. Second step is what? Whether our independent variables is significant. That is, which independent variable has a significant role for the prediction for this example. So for that, we have to see our p-value, which is in the L column. I am highlighting the independent variables and the corresponding p-value. Now again, if you see, you have to compare with my level of significance only. This is just for your reference. I'm adding this column. Okay. I'm adding this column for your reference, that is to make you understand. And I'll make a table like format to make it very clear. So level of significance is what? 0.05. So everywhere you write 0.05, 0.05, 0.05. Okay. Now I am going to change this color because we have to compare now. Now compare and put the signs. First value, that is the p-value of displacement. Is it less than or greater than the level of significance?
Greater than, ma'am.
Less
Oh,
than,
please.
ma'am.
Yes, very good. Less than, because I'm having E minus 0.6, no?
Yes.
Okay. So when you observe, please observe the complete number. It is 0.5 times 0, so it is less than, correct. What is the next one? What about the next one?
Greater than.
Correct, greater than. Weight, what about the weight independent variable?
Less than.
Less than. And what is the last one?
Less
Again,
than.
it is less. So again, I am just making it a formal white. Now, whichever is less than, that is significant. And the variable which is not less than, it is not significant. That means in our case, displacement variable is significant. Weight variable is also significant. And acceleration is also significant. But this horsepower, since it is more than 0.05, this particular independent variable is not significant to our model. That it doesn't, this variable is not useful. That is, it's not much useful for prediction. So if you take or if you not take, that is, the conclusion as a statistician is to ignore this variable, because it doesn't have a significant role in the prediction part. So this is what I was saying, when I am having multiple linear regression to perform, this is the important step, because then only you can write what is the significant model. So whichever variable is significant, that only will come into our significant model. So now, how will my significant model look? The significant model will have MPG, that is my Y, equal to beta naught, that is 47.11. Displacement I have to consider because that variable is significant. So minus 0.033 into displacement next. Horsepower value not need to take because that variable is not significant. So I will take the next variable, which is weight. So it is again negative. So minus 0.0028 into weight. I can take the acceleration also in my model because that is also significant. Minus 0.4477 into acceleration. So this is the significant model actually. Suppose if you take the horsepower also, you will get the answer. As I said, it's numeric. You will get the answer. But technically, it is not accurate. It is not, okay? So when you take only the significant value, your model would be Good. And now if you see your R square, that is when it is multiple linear regression, no, we have to generally go for our adjusted R square. And it is quite good. In simple, it was only 69%, right? But when you have added more variables, 74% variation is being explained by these independent variables. And remaining approximately 25 is due to some other reason. The fuel consumption is not only because of these variables, right? These are few. There are some more other reasons also. That some more other reason is 25%. According to this data, 75% contribution is why due to these variables. So this is how you go for the interpretation part of simple multiple linear regression. So you can just perform from your side. If suppose if you feel I have done it very quickly, you perform by your own. If you're having any difficulty, kindly ask me. Because in the next session, we will be going to a completely new topic about testing of hypothesis, which actually I have to start it today. But I'm going slow in the beginning to make you understand. Once you understand this small concept, then I can go a little fast also in the further lectures. So hence I have covered here today only regression part, linear and simple. You saw performance is very simple. The interpretation part and understanding the significance of the variable is very important here. Okay.
Ma'am,
Yes.
if in my study there is one independent variable and
Yes.
dependent variables are more.
No, ma'am. So in that, it is not regression analysis.
Okay, then how we need to go with that? We cannot bring it here?
No. For regression analysis, it is only one dependent variable, multiple independent variable.
Okay. What if it is otherwise the case?
That is all the factorization part, madam.
Okay. Okay, suppose if I want to study the impact of one variable on other variables.
One variable on other variable, yeah, okay.
But it is only one variable here, which I am indicating as independent. One variable, the impact of that variable on 3 to 4 variables.
Is your data continuous?
Yes, it is continuous.
It is measured, which type of measure it is that?
Means
you are using some measurable scale, right? It is measurable, right?
Yeah, it is actually taken from secondary data.
Okay, that is not a problem.
So how can I use
It
this
is
here?
continuous, and if you are having one dependent variable and you want to check you want to know the relation, then you can go for the correlation and then you can come to a regression for the prediction part.
But for regression, I need to take it separately because here we are taking only 2 variables.
No, in multiple I took more than one variables.
But here in this case, we are studying the impact of various variables on one factor.
Yes. That is not factor, ma'am. That is also one variable only.
Yeah,
What you are saying factors, that is all the another topic, say ANOVA.
Oh.
When we say factors, then it will come under ANOVA topics.
Okay. Are we
There is
covering
difference
that?
between factor and variable.
Okay.
ANOVA will be coming the later part. Variable is different and factor is different. In one factor, you can have different variables.
Okay. I think I misspelled it. Instead of factor, I would have used that variable itself.
Okay.
But here it is. There is one variable and is it having any impact on other variables? That is what I want to study. And there
So
is
I
only
think
one.
it might. Yes, ma'am. Continue, please.
Yeah, if there is only one variable, which is we can call it as independent. And if there is any changes in this variable, what impact is it having on the three variables, which we can consider them as dependent variables?
So that is, ma'am,
So in such,
ANOVA. What you are saying.
okay, ANOVA, we need to go for ANOVA.
To see whether there is any impact between that two variables.
Yeah.
That is not under regression, ma'am.
Okay.
Yeah.
But here when we are using this in the chart which we are getting, we are also getting ANOVA table. That is under
This
that here.
That ANOVA is different, ma'am.
Okay. Then fine.
This ANOVA table is for regression analysis to get that significant value.
Okay. So, but we
If
we are
you must
covering.
have been, if you must be seeing in the data analysis toolpath, you have a different option called as ANOVA 1 single factor, ANOVA 2 factor. If you must noticed,
Just a minute, ma'am.
you can check in that tool.
Okay. Yeah, I have. Yes, single
Yeah.
factor, two factor, and
Yeah.
two factor without replication.
Yeah, that is the limitation. For more than two factor, we say multiple. That is in the say SPSS software.
Okay. But can what I said, can we do it? Do this by using this data analysis pack?
That I have to see the structure of your data, ma'am. Then only I can guide you in that. Because just you are reading the name, that will not help me out.
Yeah.
Looking how your data is. Okay.
Okay.
We will see. We will cover that. I will just cover. Then you can. We will discuss later on about that.
Yes. Sure. Thank you. Thank you.
Meanwhile, if you want, you can share me the screenshot of your data, how it looks.
Okay. How can I share it? Share it to you?
You can share in my number, ma'am.
Okay, ma'am. I think you are in
I'm
that
there in
group.
that group. I'm there in that group. You can get it from there.
Yes.
Okay.
Thank
So
you,
we will
ma'am.
come to our topic now.
Yeah.
Okay, that is out of our topic of today's session. Any doubt?
Ma'am, I have a question.
Any doubt in the participant in this today's session on regression part? You may ask.
Ma'am, I have a question.
Yes, please.
Ma'am, why we have said adjusted R square? In previous one, we have said this R square.
When I am having single variable, then we take R square. When we are having more than one variable, we have to take adjusted R square. Because there are more than one independent variables, hence we have to take adjusted R square. It is a theoretical concept, ma'am.
Okay, ma'am.
For one variable, only R square. For multiple, we take adjusted. Moreover, it to some extent in many of the places it will be very close to, but technically when you interpret, then it's always preferred that for multiple linear regression you interpret using adjusted R square.
Ma'am?
Ma'am, can you tell how to analyze whether they are less than or more than the level of significance?
Ma'am, it is simple comparison, mathematical comparison, ma'am. We have to compare our data with the level of significance. See the column L, M, and N. Okay, we have a standardized level of significance, say 5% generally we take. That value you have to compare with our P value. Okay. So my P value is
E, what is that E in after 3.3736?
E after E, that is exponent that we say that 10 raised to minus 1, 10 raised to minus 2, 10 raised to minus 5, that is the meaning of that.
Okay,
so when I'm
ma'am.
having minus 0.6, that means I'm having 0.50. Actually, it is 60, but we have to put one decimal, na? So
Okay, ma'am.
0.50 and that number. So which is approximately 0.
Okay, ma'am. Thank you.
Yeah, welcome.
Ma'am,
Yes.
ma'am, I think I have to thank you for, because I have learned this regression now. It is very clear. But I
Welcome,
want
sir.
one more, I want one clarification, ma'am. There is something called logistic regression, right, ma'am?
Yes, that is not linear, that it comes under non-linear, sir.
Okay, okay.
So that is
So,
our, if you have seen, it is not performable in Excel directly
okay,
because it is not continuous data. We have dichotomous data in that,
I see.
which I will show you on the last lecture of SPSS.
Okay, ma'am. Then one more thing, ma'am. There is something like I have seen like in certain research, they are using this mediating factor, right? One
Mediating
on the
factor.
other, but there is one more variable, mediating variable or something. Whether this
That
is
is
having
again, not directly in linear regression. It's like your factor analysis, different. It's a non-linear part, sir.
Ma'am, will you be covering this one later on? This
No, so
mediating?
that is all a higher level part. It is not in the lower beginner. Not, it's not a beginner's learner, sir.
Okay, okay,
It
ma'am.
is totally a different topic. Yeah.
Okay, next time please organize something on that also. Organize. I'll just request the
Yes,
organizers
sir.
for
Sure.
that also. Anyhow, thank you so much, ma'am. I have
Yeah,
understood
sure.
this regression very well.
Yes, sir.
Thank you.
Yes. Thank you, sir. Welcome. Thank you so much for your.
Thank you.
Yeah, we have another 5 more minutes for doubt session. Anyone, please, you can
Ma'am?
raise. Yes, yes.
Ma'am, can you please just tell me like how to write this written format of how to write this displacement and horsepower? Like I understand what is the relationship and everything, but in a paper we have to write. So the wording, what should be the wording of it?
This one, ma'am, which I have written in the first example. You have to state the hypothesis first. You will write overall the model is significant. That is, in null hypothesis, you will write overall the model is not significant. In alternative hypothesis, you will write overall the model is significant. If you see the simple regression where, that is where I have given all the statement. Can you see that screen?
Yes, ma'am.
Yeah. So this is the wording you have to write, ma'am. And then you will write the decision which we have made. So here the p-value is less than the level of significance. Hence we reject the null hypothesis. So I'm just making it highlight for you. This is the statement which you have to write it down for the conclusion.
Okay.
And finally, then you will write the significant model. And then you can give the R square interpretation. You see, or one more I have to show you. We have seen the scatter diagram visualization, right? With that, I was able to understand that there is an decreasing, that is negative relation. That means if one variable increases, the another decreases. There is one more numerical measure which we can get the proper idea about the two variables. When you go to data analysis toolpath, you are having option called as correlation. C for correlation at the top only. So you can click on that. You can select the data sets. It is whatever you want. The complete. You can take one and one-on-one, or if you want to take all the variables together also. So I will show you for the multiple one how it looks. First let us start with the simple one. Data analysis, correlation. Okay. I'm going to take the two variables. Of course, it is grouped by column. My data is column wise only. Label I have to take output range, take any one cell and say okay. So if you see here, my correlation value which I have got between MPG and displacement, it is negative, right? So if it is negative, it is called as correlation coefficient. Correlation between the two variables, right? If it is negative, then I can say that it is inverse relation. That is negatively correlated. So if one increase, the other decrease. A very good understanding for that. Just I am highlighting you two values. The two observation, if you see here, MPG I am having 26. Corresponding displacement is 156. MPG I am having 22, decreased, but my displacement is increased. This is a very good understandable example to make it clear what is the meaning of negative correlation. So one increase, the another decreases. So that is what the correlation meaning here for this data. You can do it for the complete one also. Okay. How? Same way only the steps are going to remain same. You will get a very good matrix type like a tabular form. Data analysis, correlation. You select the complete 5 columns. Okay. And give one cell. Okay. So you will get like this in a tabular form, very well structured. Of course, the diagonal will be one. Diagonal is one means what? It is between the same variable. Between the same variable, we are not going to check the correlation. It is one and the other. So displacement and MPG, it is negative. Only acceleration and MPG is positive. If you see acceleration and MPG, the relation is positive with them. If you see the displacement and horsepower is also positive. Okay, here we will get the understanding relationship between the two variables. So that is done by, because when I'm doing scatter plot now, at a time I can do only two variables now, because it is 2D visualization. But when you do with the correlation coefficient, you can take all the variables together in that. And they can get a clear-cut idea about the correlation between the different variables present.
Ma'am, any book that you can recommend that we can refer for understanding more about all this coefficient, correlation, regression?
Ma'am, nowadays there are so many books. Any author written as research methodology, because nowadays they give all the basics from the basic. So any research methodology book you can, ma'am.
Okay, ma'am. Thank you so much.
Yeah. So that's all today from my side. I thank all the participants also. You are performing along with me and responding. So it makes an interest for me also to go ahead. And participation is very important in this type of session. So thank you once again, everyone. And I hope this will
Thank you,
continue in
ma'am.
the remaining 4 days also.
Thank you so much, ma'am.
Yeah, you're welcome.
Thank you, ma'am.
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 Welcome.
Thank you, ma'am.
Ma'am,
Yes.
Thank you,
ma'am, like, are we going to start with SPSS also?
Not tomorrow. We have to do some more thing in the Excel. Then only after that only I will start with SPSS.
Okay, ma'am. Ma'am, in SPSS, like, are you going to do with the SEM and all, ma'am? SEM model?
No, ma'am, not that all in detail. Not that high part. We are going to do the basic beginning level only, ma'am.
Okay,
Because in
okay.
data entry, there itself, we will take so much time to make understand all the data entry itself. It takes times to understand. That much
So,
will be not able to cover, ma'am, all that things.
okay, okay. Like whatever we are learning in Excel and the same we'll
Yeah.
be doing in SPSS also, no?
Yes,
Right?
yes,
Yeah,
yes.
ma'am. Thank you. Your session is good, ma'am. So good. Thank you. Thank you.
Thank you so much, ma'am.
So I would like to wholeheartedly thank once again the workshop organizers, especially Dr. Bennett sir, and I especially thank Shobana madam for giving us for enlightening us about the research process, that is hypothesis testing in MS Excel for a small sample, and also hypothesis testing in MS Excel for a large sample. I'm sure that it will be very useful to all the participants who have participated in this workshop. I once again thank you all for being patient enough, and also we received a lot of information, and thank you, Madam Dr.
Thank you,
Shobana.
ma'am. Thank you so much.
Thank you, ma'am.